Hello, in this module we will go for matched analysis, second part with R. Matched analysis is important to make a platform between cases and control, where equal opportunity are given both group, that is cases and control, to make a conclusions about disease exposure on disease presence or absence. Since odds ratio is the suitable tool for case control study, so matched analysis results is also oriented through odds ratio. Through logistic regressions we can get the inference about odds ratio for regressions coefficients value. So, in logistic regressions, if we consider the exponential value of regressions coefficients, then we can get as a odds ratio. So, in this module we will see how to work with logistic regressions and get inference about odds ratio for handling data as matched analysis. We will also put some suitable scenario where conditional logistic regression is suitable or applicable to get inference through odds ratio. Fisher exact test we will see here to idea about the exposure and disease presence or absence. In this module we will see how to plot the difference values of odds ratio into graphical format and make statistical inference from that. Let us start work on matched analysis through R with suitable example.
Here we will see about the 1:n matching analysis in R, logistic regression for 1:1 matching, conditional logistic regressions using R to getting the matching analysis, thereafter exact conditional test for 2x2 tables of count data, plot the p-value functions for one of 2x2 table, and statistical inference on 2x2 table analysis. Difference is there the analysis of epimedical data using R and epicalc. The library named with epicalc we will use here, and these materials in these modules can also be cited from this book of analysis of epidemiological data using R. It is an open source book. So, data is on VC1 to 1, and after that we are calling the use VC1 to 1, and when we put the head of dot data where the data is assigned as VC1 to 1, then the first columns is match set, second column is case, third column smoking, fourth column rubber, and fifth column alcohol. So, match set as basically standing for matching setting, and for 1 to 1 informations is there, and first is and second column since is putting as case. So, if the patient is present as case, then it is given as 1, otherwise given as 0, and thereafter the status of those patients given as if they were smoker, then it given as 1, otherwise 0, and like same the dichotomous variable rubber and alcohol also been considered. So, if the rubber was there, so they are given as 1, and if it is not there, then given as 0, and if they were alcohol taker, then it is given as 1, otherwise 0. So now this is the data set, and matching indicator or variable can be defined as the first column, that is match set is there, and one representative is taken from the, if you compare the match set and case both column, then we will see the in match set first row is for 1 and second row also 1, whereas in case column the first row is as 1 and second row is 0. So one individual is considered from cases, those are having smoking, rubber 0 and alcohol also not there, and another cases, another individual are considered from control, that's why cases is given as 0 and it is represented through the column row 2, who was also smoker and who was also not having rubber and also having not alcohol taker. So this way, and if you go for the third row also, if you see the third row and fourth row, they again it's matching as given as match set is given as 2 2, whereas first one is having cases, second one obtained from control, and again their status was as given as a smoking yes, whereas one individual was from cases, individual was having rubber no, but control was from yes, and already the alcohol taker as a cases was from alcohol taker, control was not having alcohol taker. So this is the ideal data set. So for matched case control analysis, and for your own data set or in another data set, we have to prepare the data set in such a way to go for further analysis. So this is a basic data set we are illustrating. Now we are going for analysis. Now there is a functions called reshape. That functions can be used to reshaping the parameters and with wide with 3. Like here we are using these time variable as cases and v dot name as a smoking, rubber, alcohol, that is variables considered here, and matching data set is considered as a id variable, that is id var, and the direction is what. So we are now changing our data set into white format, and for that we are using the reshape here, and the whole function we are assigning as a white. Now when we are calling head with wide 3, so first 3 observations can be seen here, where mat set is having 1, 3 and 5, where smokers dot 1 is given as 1, 2 and 3, and rubber dot 1 both were having, all were having actually yes, alcohol dot 1 first 2 were having not alcohol taker, but third one was alcohol taker, and smoking dot 0 also 0, 1 and 0, rubber dot 0 also 1, 1, 1, so they were also having presence, and same for alcohol dot. So this is the one functions we can use the reshaping or change the format of the data. Now we are going to preparing the data, and for that we are using the function table, and into this table functions we are assigning variable smoking dot 1, smoking dot 0, so smoking yes and smoking no indicator is used, whereas to forming the table, smoking in cases and smoking in control is assigned. Now we can see smoking in control, those are having 0, there is no, and those are having 1, that is yes, is obtained by a 2 by 2 table, that is 0, 5, 5 and 16. So first AB, if you form as a ABCD that we have seen in earlier module to prepare the odds ratio, then A is basically 0, B is 5, C is 5 and D is 16. From this table we will go for further for analysis with odds ratio, and we will make the interpretations. Now the functions match tab we will use here. Here cases, that is case smoking is considered with strata equals to mat set is considered. Now the same table is formed. Now when we are using the match tab functions, then as a result we are getting these odds ratio, and the odds ratio is obtained by mental Hensel test, and the estimates of odds ratio is coming as 1, and with the maximum likelihood estimates is used here to get the odds ratio estimate with the confidence intervals 0.29 to 3.454. So it can be stated that those who are having exposure and not having exposure, both are having equal kind of disease. So there is not any difference between cases and controls in terms of exposure. So exposure is not having any role for disease. That can be stated because the odds ratio is coming as a 1 here. Now we will go for 1:n matching. Now like earlier one, if we put the match tab and case smoking and strata is equal to match set, so now number of cases exposed, number of controls equals to 1 when we considers. So here what we will do, initially we will do with, in case of 1:1 we will go for 1:1 matching, after that 1:2 matching, and like that we will go for 1:n matching. So here we are not going for 1:n time consuming procedure. So here as a illustration purpose we are proceeding only for 1:2 up to 1:2. So first is considers when we are using the match tab functions, and cases and smoking is considered with strata is equal to match set. So we are getting for 1:1, so number of controls per cases is considered equals to 1. That's why is given number of controls equals to 1 with number of control exposed and number of cases exposed. And again we are forming a table with 0, 1, that is control exposure not and control exposure yes, and as well as cases exposure no and cases exposure 1. Now again number of control is considered as 2, that is per cases number of control is considered 2. So 1:2 cases is to control is considered, and then we form the table where this 0, 1 and 2, 0 is considered. So till now for 1:n matching the odds ratio is coming through Mantel-Haenszel method is coming 1.98 with his confidence intervals 0.678 to 6.29. So in case also it can be stated that odds ratio is equivalent to 1. Here in this function of match tab we are getting two kind of odds ratio. One is by Mantel-Haenszel method, another one so by the MLE, maximum likelihood estimate methods. So for both cases it's coming near to 1. One is 1.98 and another one is 2.06, but since the confidence interval is between 0.67 to 6.29, so it can state there is no insignificance value of odds ratio. So in terms of cases and controls, exposure having equal role, that can be conclude from these results. So this is the way we can go for 1:n matching. So in case of rare disease, it is to be noted that we can go up to n as 6, and there is not many to go for more than n equals to 6, but 1:1, 1:2, 1:3, 1:4, 1:5 and 1:6 can be considered as cases on control ratio. For non-rare disease 1:1, that is cases versus control, can be considered. So this function is generic functions match tab that can be used for 1:2 in any terms, but again to be noted that we should not go for more than n equals to 6. So the results can also be obtained for n:6 here. Now we are going for functions. So you have seen that when we are going for logistic regressions, the link functions binomial is useful to perform with the logistic regressions where we are having functions GLM. So GLM functions, generalized linear model, is used in R here, and the dummy variable outcome dot difference what is been generated here is considered as a response variable, and obviously it is having two endpoints, either 1 or 0. So its presence or absence is being considered, and for logistic regression we have to consider the response variable as binary, so as yes or no, and smoking dot difference -1 is considered as a covariates of interest, and it's also eventually became as a discrete variable, and comma binomial is mentioned because we are going for link functions as a binomial to perform the logistic regressions into GLM. The whole set of things is assigned as a co.lr1, and where we are calling the summary co.lr1, we are getting the results, and as a result we are getting the standard estimates of smoke.diff is 0.00, with standard error 0.63, z value 0 and p value 1. So it's stated that both are having equal odds ratio, means both are having exposure and not exposure, smoking yes or not smoking yes, having equal effect on disease, on cases. The model fitting criteria can be stated by this 38.04, that is obtained by EIC. Now in the same scenario, if we replace these covariates of smoke.diff by alcohol.diff or by rubber.diff, then we can get different AIC. In addition to that, we can consider the adhesive model where smoking.diff and alcohol.diff as well as rubber.diff can be considered. So we will get the different AIC value, and in that scenario these AIC value is the minimum can be considered the best fitted model. So however, we are not going here the fitting criteria, but if we consider, then AIC can be used to check the model fitting criteria. Now we are going to get the confidence interval of this odds ratio. That odds ratio, the p value we got 0, 0, p value we got 1, and regressions coefficients value as 0, 0. So if we take the exponential of 0, that will be 1. So obviously here odds ratio is coming as 1, because the regressions coefficients value obtained by logistic regressions, if we take the exponential of that regressions coefficients value, we will get the odds ratio. And now we are putting the exponent exp within parentheses conflict of dot default of co-LR1, and we are getting the 95% confidence intervals with 0.2895 to 3.45. Obviously, since this window is touching the value of 1, we can state this odds ratio is not significant. Now if we put the functions called exponential of conflict of default, then we will get this logistics dot display of co dot lr1, and again these wall statistics test value and likelihood ratio test value can also be obtained, and corresponding EIC value, again we have seen earlier, can be used for model fitting criteria. And now we are putting the exponent exp within parentheses conflict of dot default of co-LR1, and we are getting the 95% confidence intervals with 0.2895 to 3.45. Obviously, since this window is touching the value of 1, we can state this odds ratio is not significant. Now if we put the functions called exponential of conflict of default, then we will get this logistics dot display of co dot lr1, and again these wall statistics test value and likelihood ratio test value can also be obtained, and corresponding EIC value, again we have seen earlier, can be used for model fitting criteria. Other steps, now we are using this adhesive model. Initially we had used smoke.diff only, now we are using smoke.diff and alcohol.diff -1, again with binomial logistics, and logistic display is used. So as a result, we are getting the odds ratio for smoke.diff is 1 and alcohol.diff is 4.5, whereas this confidence interval is coming 0.3 to 3.5 for smoke.diff and 1 to 20.8 for alcohol.diff. So again, alcohol also having no role for cases that can be stated, because here since the odds ratio confidence intervals is coming not significant. Now we will go for conditional logistic regressions, and that conditional logistic regression is can be done with the library called survival, and C-logit1 we are assigning through the functions of C-logit. Though C-logit is stand for this conditional logistic regressions, where cases is considered as a response variable, and smoking and alcohol with the strata of match set is considered. And now we are calling the summary of C-logit1, when we are getting these regressions coefficients value obtained through the logistic regressions. For smoking is -0.314 and a corresponding exponential of coefficient value 0.73 and standard error 0.708 with the z value minus 0.44 with p value 0.66. So now again for alcohol also we are getting coefficient value 1.57 with exponential of coefficient 4.81, standard error of coefficient 0.803, z value 1.95 and p value 0.05. So here in this case we are getting that as a summary logistic the results that both are having, smoking and alcohol having no role for cases, and corresponding odds ratio value coming as a 0.73 for smoke and alcohol 4.81. So again this R square value, the likelihood ratio test value and word test value and score rank, log rank test value can be seen, and we can compare this match to match here. One of the utility of this conditional logistic is that for matching analysis is that we can get the results in terms of odds ratio after applying these conditional logistic regressions, and for different factors can be matched at a simultaneously through application of conditional logistic regression. Now to get the results display, again we can use the C logistic dot display with C logit 1. Again like earlier slide we are getting these results for smoking and alcohol. Again this corresponding odds ratio with confidence interval and adjusted odds ratio value with p value and p value obtained through word test and likelihood ratio test is being observed. Now we are going for another library, that is exact 2 cross 2 table, and we are using this the library to prepare the 2 by 2 table. The matrix functions again can be compatible with this library, and again we are using the first cell value as 60, first row second column value 120, first column second row value as 120 and second row second column value as 50, with dimensions we are putting as a group A and group B, and column wise we are putting event and no event, and this is the results obtained for group A and group B, and even and not even. And now we are going for preparing the Fisher.test to perform this group wise having difference or not, and p value is coming highly significant, and as the alternative hypothesis is not equals to 2 with confidence interval 0.1 to 2.33, and odds ratio estimates is coming 0.20. So here since in this table we can state that those who are having group B they are having more chance to having not event, and those who are having in group A these are having more chance to being event. So that is the interpretations can be. So group B is having protective factors in comparison to group A, that can be inferred from these results. Now we are using, in addition to the Fisher.exact, we are using the TS method as a mean likelihood. So that will give us the result with minimum estimates of the odds ratio. So minimum likelihood estimate through minimum likelihood procedure, and again we are getting the same results as a 95% confidence interval 0.1 to 2.33 with sample estimate of odds ratio 0.20. The same interpretation can be obtained here. Now TS method mean likelihood has been replaced here by central, and it will give us the central Fisher's exact test. Slightly changes in terms of p value has been observed, but in terms of confidence interval of odds ratio is not been changed, and again for odds ratios estimates that came again 0.20. So the as a TS methods to get the estimates of odds ratio and confidence interval we can use the mean likelihood and the central as well. However, here no estimate difference being observed, but in terms of p value the difference being observed. Now we are going to plotting the odds ratio value, where through y-axis we are having the p value, and x-axis we are giving these different odds ratio value obtained. Now we will plot these headlines functions that we have seen in these odds ratios Fisher exact test, and showing this align function is coming as a red color, and that is another way to exploring the odds ratio and graphically represent the odds ratio into analysis. Now another functions to go for odds ratio testing, that is binomial test, where with 13, 25, 8 and 18 is being considered, and melded binomial test for odds ratio, and here we are getting the confidence interval for odds ratio as a 0.17 to 3.00, and the odds ratio is being considered as P2 with 1 minus P1 divided by P1 with 1 minus P2, and as a result we are getting the estimates of odds ratio 0.73. So the data is new here. Earlier here the same data set has not been used. Another contingency tables being formed, and with 13, 25, 8 and 18 cell value, and the results is. So another way we can get the odds ratio value with the functions of binomial test. Now the odds ratio can also be obtained by the functions exact 2 cross 2 table with the matrix, and this difference of the matrix can be used that 8, and if you are having second cell value as 18, so 18 subtracted that 8 can be used, and the third cell value is having 13 and fourth cell value is having 25, so for 25 minus 13 can be used, and as a TS method we can use the central, and the results from the same data set that we have used the binomial test we are using with exact 2 cross 2 table test, and we are getting different confidence interval. Initially we got confidence interval with 0.17 to 3.00 having p value 0.85. Here we are also getting p value 0.858, but the confidence interval is 0.18 to 2.92 with odds ratio 0.74. So this is the way we can prepare the odds ratio for matched analysis. Here we have seen how to go for different way, how to go for 1:1 and 1:n match analysis, and how to make the interpretations about the statistical inference.
In this module we have seen how to work through R for data analysis, where we are concerned about the matched analysis. We have adopted logistic regressions as a functions from GLM. We have also seen how to generate odds ratio value through application of conditional logistic regressions. We had plotted data of odds ratio into graphical format, and here we have also make statistical inference about Fisher exact test.